All right, it says how many integers between 100 and 150 inclusive, meaning that the 100 is included and the 150 is included, can be divided evenly by neither 3 nor 5. All right, so let's use this. Let's see, I'm going to use U be the set of all numbers between 0 and 150. So it's going to be 100, 101, and so on, and 150. Right? So we know that the number of elements, so this must be a little bit tricky, but the number of elements in this set would be how many? All right. So it's tempting to say, 150 minus 100, so it's 50. But you actually forget to count 100 that way. So it's actually there are 51 numbers are in there, right? So then, let's see, A, I'm going to use A. I don't have a clever notation. So A, so this is the number divisible by, I'm going to just say divisible by 3, right? And I'm going to use B for divisible by 5, right? All right, so let's try to find, let's see, so this is divisible neither by 3 nor 5. All right, so let's do that. So let's do the easier one. So how many are divisible by 3? All right, so we are looking for, so number of elements in set A. All right, so divisible by 3. So every 3 numbers, you have a number divisible by 3, right? So we have, let's just go through the division. We have 51 consecutive numbers, and I'm going to divide by 3. So it's going to be 3 and 21 and 17. So 21, and it divides evenly. So there are 17 sets of 3 numbers. So we know that each set has one number divisible by 3. So we know that there should be 17. Right? We got that. All right, how about 5? Right? So we can just do the same thing. So you have 51 consecutive numbers. Every 5 numbers, you see a number divisible by 5. So, but this one's a little bit tricky. So it's a 5. And then you bring it down, so it's a 0, so remainder is actually 1, right? So you have at least 10 numbers divisible by 5, but you have to be a little bit careful because you have a 1 left over, right? You have one more number that could be divisible by 5. So for example, you are going from 100 to 150, right? So you can use the first 50 of them. We know there are 10 numbers that are divisible by 5. But the last number, in this case 150, you can easily see that the 150 is also divisible by 5. So you actually have 11 of those. So n, the number of numbers that is divisible by 5 is actually 11. Right? All right, then we want to find, let's see, how about this one? If you do A intersect B, so we are counting some of them twice, right, for A and B. So this is going to be divisible by 3 and 5, right? All right, so this is going to be, so the number, so in order to be divisible by 3 and 5 at the same time, what you do is you're looking for the multiples of common multiples, right? So least common multiple between 3 and 5 would be 15. So every 15 numbers, you see a number divisible both by 3 and 5. All right, so we know that the 51 divided by 15. All right, then you can see, let's see, it's going to be 3. Then you have 45, and remainder is going to be 6. All right, so you have at least 3, but the last 6 number, or actually you can do the first 6 number, it doesn't matter, but the last 6 number, you see that 150 is divisible by 15. So there are actually 4 of them. All right. So let's look at a Venn diagram. It probably makes it easier. So what are we looking for? All right. So here are the numbers. So there are 51 numbers in there. And here is the numbers that is divisible by 3. Right? Here are the numbers divisible by 5. Right? And there are 4 of them divisible by 4. So I'm going to start putting numbers in there. So it's going to be, both is going to be 4 there. Right? But we know that there are 17 numbers are divisible by 3, and 4 of them is in there, so that this should be 13 out here, right? And by the same way, 11 numbers are divisible by 11, are divisible by 5, and 4 is already in there, so it's going to be 7 is out here, right? Then what you're looking for is the number evenly divided by neither 3 nor 5. So we are actually looking for these guys out here, outside A and outside B at the same time, right? All right, so which means that we're looking for the number that is the complement outside of A union B. So we can do A union B complement, right? But to do that, all you have to do is find the number, total number, and subtract the number inside A union B, right? So how do you find A union B? So we know how to do that, right? So total number is 51 minus, inside this union, you're going to have 11 over here, and it's going to be 13 more, so it's going to be 24. So subtract that 24. All right, so it's going to be 27. All right, hopefully that answer is right there. All right, so there are 27 numbers that are not divisible by 3 and also not divisible by 5. All right, that's it. I hope that this was clear.